Okay, so I'm Professor Mayes-Tang, and I'm just going to review some polynomials and how to add them, and hopefully do it in a little bit of a more accessible way. So one of the things that I like to point out is that variables like x and y are just stand-ins for numbers. They're just like symbols. Or that's the way that you can think of them. So other symbols that we can use are like hearts, or stars, or smiley faces, like emojis. These are also symbols. And sometimes they're like a little bit more friendly and accessible. The other thing that we should ask before we embark on anything is like, why are we doing this? And actually the answer to this question is a little bit difficult to answer. There's like not really, honestly, a great reason why you're doing this at this point. And I think that the big lesson here is that you're learning to recognize patterns. And in your life, beyond mathematics, you're going to have to learn how to recognize patterns. For example, patterns in data that you look at, patterns in research that you look at, patterns in text that you look at, and looking at patterns in symbols is just one way to start this journey of looking at patterns. And this is like a real kind of 21st, what we call a 21st century skill. Because it's used everywhere. So I'm not sure if that seems like a very satisfactory answer, because it's a really big general thing, but that's why you're doing it, right? You're doing it to build more general skills. So let's start off looking at just adding a couple of polynomials that we make out of symbols. Now, what is a polynomial? A polynomial is when we add or multiply a bunch of symbols together. So here I have a string of symbols, hearts, that I've chosen to add together. I don't have any multiplication, and a bunch of stars that I've chosen to add together. So I have heart plus heart plus heart plus heart plus heart, all added together, and then star plus star plus star. So if I decide to add these, the addition just means that I put an addition sign between them. I literally decide to put an addition sign. So I have to count heart plus heart plus heart plus heart plus heart plus heart plus star plus star plus star. Okay. Now, in order to save some time, in order to save some pen space, you might say, I don't really want to write out all those hearts. I've recognized a pattern here that I actually have 5 of the same thing I'm adding together, and then 3 of the same thing, the exact same. So 5 same and 3 same. And if I do that, I notice that, like, okay, well, I have 5 of the exact same thing I'm adding together, 3 of the exact same thing I'm adding together. We can combine them to save some space. And so we can write, we have 5 hearts. Okay, so we have 5 hearts plus 3 stars, and that's the shorthand way of adding together, or of expressing this idea. Now, we don't have to write it like this, but this is kind of the summary way. Another way of writing this would be to write a heart plus a star plus a heart plus a star plus a heart plus a star. And then how many hearts would I have left over? I'd have 2 hearts left over. So I could also write it like this, and that's perfectly acceptable as well. So there are many, many different ways of writing this. And why can I write it like this? I can write it like that because addition allows us to switch order. The formal way of saying that is that it allows things to commute. Commute is the fancy word. So let's look at another example. Here, again, we have a polynomial because we have a bunch of hearts or symbols added together and multiplied. So we only have multiplication symbols, those are the dots, and we have addition symbols. And then we're trying to add it to another polynomial that's just made up of star symbols. Again, multiplication and addition. So if we wanted to add these together, rather than writing them separately, we would just write them together. So we have a heart times a heart plus a heart plus a heart times a heart times a heart plus a heart plus a heart plus a star times a star times a star times a star plus a star plus a star plus a star times a star. Okay, so we have a lot of symbols there all in a row. Now we can switch them up because addition commutes. So I could write something like, maybe I could decide actually to write all of the single things together. So maybe I'll write all the single hearts first. So I have 3 single hearts. Heart plus heart plus heart. And do I have any single stars? Yeah, I have 2 single stars. So plus star plus star. And then maybe I'll write all the doubles. So I have a heart times a heart. Heart times a heart. And then over here I have a star times a star. And then I have 3 hearts multiplied together, so that'll come next. Heart times heart times heart. And then I'll finish up with the last thing that I have. I'll put it on the next line, just nudge it in here. Star times star times star times star. Okay. So in this example, I've chosen one way to switch these up, but I could switch them up in any way, and that would result in a ton of different options. Now, again, mathematicians like to find patterns, and we like to try to combine things to make them easier to write, because you might have noticed like star times star times star times star. I would make a mistake probably counting those out. I might have already made a mistake that you've caught. So I can start to combine some of these things. So I notice here that I have 3 hearts. So I can write that I have 3 hearts. And then here, I have 2 stars. Stars. Now, I don't seem to have any other patterns, right? Like, I don't have any other things that are alike. So we might have to write these all out fully. The question becomes, how can I write this heart times heart in a more compact way? Well, that's where exponents come in, right? A heart times a heart, a more compact way to write that is to write heart squared. A heart times a heart, heart squared. Two like things multiplied together. The compact way to write that is to just write it as an exponent. So the next term becomes star squared because I have a star times a star. Two of the same thing multiplied together is star squared. Okay, so pause it here. Try to write down the next two terms in a more compact form. Okay, so hopefully you've paused it and you've come up with 3 hearts multiplied together. We can write as heart cubed. And then 4 stars multiplied together, we can write as star to the power of 4. And when I say heart cubed, that just means heart to the power of 3. Okay, so this is a more compact way to write this big term. And you might ask, well, why can't we write now 4 times heart to combine these two terms? But notice that they aren't actually the same. A heart and heart cubed are 2 different things. They're 2 different things that can't be added, because that would be like adding these 3 hearts and the 3 hearts multiplied together. And those are different fundamental things. We have single hearts and we have triple hearts, and those things can't be added together. Okay, next up we have this example. And notice in the second line we have a polynomial that has hearts and stars mixed up. So this would be like if you have x's and y's mixed up in the same polynomial. So again, if we just added these simply, one way to write the addition of these 2 polynomials is heart times heart times heart plus heart plus heart plus heart times heart plus star times star plus heart plus star plus heart times heart. Okay. But again, we might want to write this all more compactly. Now, again, we could switch up the order. I'm not going to do that this time. This time, I'm just going to try to write each term in a more compact way first. So I notice that I have 3 hearts multiplied together. So when I have 3 hearts multiplied together, that's the same thing as heart cubed. So then I have plus heart plus heart. And in the next one, I have 2 hearts multiplied together. So that's the same thing as heart squared. And then in the next term, I have 2 stars multiplied together. So when I have 2 stars multiplied together, 2 of anything multiplied together is that thing squared. So maybe I'll write this down because I've been doing this a few times. So rule, actually the definition, anything times anything else equals that thing squared. Or anything times anything equals that thing cubed. And so on. Okay, that's what I'm using. Okay, and then, oops, just moved over. Okay, and then I have 2 hearts alone. I have a star alone. And then I have 2 things multiplied together. I know from my rule now that that's going to be a heart squared. Okay, So now I can see this is shorter, this is better, but I still have some things that could be combined. I have like heart plus heart plus heart plus heart plus heart. That's pretty long to say. So maybe I can start counting those hearts. So I have a heart plus a heart plus a heart plus a heart. And I could move all of those things together because we can switch things around in addition. So actually, let's do that. Let's put all of the things that are alike together. So I have a heart cubed, and I don't have any other heart cubes, so I'll leave that alone. And then I have a heart plus a heart here. And then over here, I have a heart plus a heart. So let's put those together, heart plus a heart. Okay. And then my next term here is a heart squared. And I look and I see, well, right at the end, I have another heart squared. So I'll write that next. And then I have a star squared. Let's see if I have any other starred squareds. No, I just have a lonely star at the end. Okay. So let's read out this whole polynomial that we have here. We have heart cubed plus heart plus heart plus heart plus heart plus heart squared plus star squared plus star. Anytime I read out those repeats, I could combine those. So it's heart plus heart plus heart plus heart. That's 4 hearts I read out. So I have 4 hearts altogether. And same thing with this heart squared plus heart squared. That can be combined too, to give me 2 heart squareds. And then I don't have anything else that's alike. But notice that if I have heart plus heart plus heart plus heart squared plus heart squared, that doesn't make 6 heart or 6 heart squared, because a heart plus heart squared, not the same thing at all. Okay, need to be exactly the same when I read them aloud. Okay, final question for right now. So I have 2 polynomials. They both have hearts. They both have stars. Now I know they're polynomials because the things are just multiplied or added. So I am going to, actually maybe in this case, I'll take a different tactic. So rather than adding them together right at the beginning, like I was doing before, let me make each term simpler before I add them together. Why don't I do that? So I'm going to notice that when I have a star times a star times a star, that's equal to a star cubed. Something times something times something is always equal to something cubed. By the same rule, something times something times something is equal to star cubed. And again, the same rule, something times something times something is equal to that something cubed. And, I have one more. Something times something is equal to that something squared. And I think everything else is alone. Okay, so let me rewrite these polynomials. So the top one is star cubed plus heart plus star cubed plus star. Oops, I forgot the cubed. Okay, and then the second one is star cubed plus heart plus star squared plus star. Okay, now I can simplify each of these polynomials before I add them, right? Notice that I have a repeated star cubed. So if I was reading these polynomials, I could say star cubed plus heart plus star. So I have those 2 star cubes plus the heart plus the star in the first one. And then I want to add that to the second one. Has just 1 star cubed, but has a heart plus a heart next to each other. So I can write star cubed plus 2 hearts plus star cubed, or plus star squared, I should say, plus star. Okay, now I'm finally going to add them because I've done as much simplification as I can, I think. So I get 2 star cubed plus heart plus star plus star cubed plus 2 heart plus star squared plus star. Now let's put the things that look alike together. So let's start off with all the single things, the things that don't have powers at the beginning. Okay, so I have a single heart and 2 single hearts first. So I'll do a heart plus 2 hearts. And then I have a single star in 2 places. And then do I have any squares? Yeah, I have 1 square. I have 1 star square. And then I have a couple of cubed stars, or stars to the power of 3. So I have 2 star to the power of 3 plus, I guess maybe I should use a different color. 2 star to the power of 3 plus star to the power of 3. There we go. Okay, and now that things are next to each other, we can see easily that we can group them. So heart plus 2 heart, well, I have a total of 3 hearts. When I have 1 heart and I add 2 hearts to that group, I'll have 3 hearts total. And then a star plus a star gives me 2 stars total. I only have 1 thing in this next group, a star squared. And when I have 2 groups of 3 stars multiplied together and 1 group of 3 stars multiplied together, that will give me 3 groups of 3 stars multiplied together. Okay, and that's as far as I can go. So if you're doing these problems with x's and y's, the exact same thing works. X's and y's are just stand-ins for numbers. They're just symbols, and your job is to just recognize patterns and try to combine them.